I, Mansi Solanki, welcomes you in Anvira Online School. Today we will study about our chapter number 10, straight lines. For studying the straight line, you have to recall your last concepts of coordinate geometry. As we know that we had studied coordinate geometry in our last class 10. The chapter is coordinate geometry. I think you all have a proper knowledge of coordinate geometry, but before we start the straight lines, first you recall all the concepts. So we will start from the basics. As you know, for any point to locate in our Cartesian plane, we have to find its dimension on x-axis and y-axis. Let us suppose I have a point x comma y. How can I locate it on Cartesian plane? Then I have to draw the x-axis and y-axis. For x-axis, I have the point x that I just have point x and y. Here it doesn't gives us the values. Let us suppose I have 2, 3. How can I plot this on Cartesian plane? Then for this I have to go 2 units in x-axis and 3 units in y-axis. So here I can locate the point 2, 3. As after the location, we have already studied the distance between 2 points given on a Cartesian plane, the length of the line and the distance between 2 points, the area of triangles and the area of how we find the collinearity of points and all. So let us start from the basics, that is the distance between 2 points. Distance between let us suppose I have point A and point B. On a plane locating x, y1 and x2, y2. How can I find out the length of AB? Then for AB, we have the formula under root of x1 minus x2 to the power whole square y1 minus y2 whole square. As you have recalled, what is the distance between A and B? How could I find it out? I find it out by the formula x2 minus x1 plus y2 minus y1. Now, let us take an example. Let the coordinates of A is minus 3, 4 and coordinates of B is 6, 2. How could we find the length AB? So we know that AB is given by the formula x1 minus x2 whole square plus y1 minus y2 whole square. So here I put the values. Here x1 is minus 3 plus 6 whole power 2 addition with y1. What is our y1? 4 plus here AB is 3 square plus 6 to the square. 9 plus 36, that is under root 45, that is 3 root 5 centimeters. Okay, if it is in units, then it can be written in units. And if it is given in centimeter, you can write it as centimeter. So I hope you recall the distance between 2 points. Now we will talk about the section formula. What is a section formula? If two coordinates are given and the third point divides the line in the ratio m ratio n, then how could you find the formula for this coordinates x comma y? A1 is our x1 y1 and b is our x2 y2. Then for x we have to write it as mx2 plus nx1 divided by m plus n. Similarly, for y coordinate I can write it as m by 2 plus n by 1 upon m plus n. If the point is midpoint, if C is the midpoint of, if C is the midpoint of A comma B, then we can write it as x is given by, if it is a midpoint, then it divides both in the same ratio, either it is 2 comma 2, 1 comma 1 or m comma n. So I can write it as x1 plus x2 by 2 and y coordinate can be given by y1 plus y2 by 2. So here distance between 2 points we can find it out by this formula and the section formula. Section formula is given by x, for x coordinate mx2 plus nx1 upon m plus n, and similarly for y coordinate m by 2 plus n by 1 upon m plus n, where m and n are the ratios in which the C divides the line segment AB, and x1, x2, y1, y2 are the coordinates of the respective points. Now the next topic is, if we had given the vertices of a triangle, if we had given the vertices of triangle, how can we find out the area of triangle by using coordinate system? So let I have a triangle ABC where the coordinate of vertex A is x1 y1, coordinate of B is x2 y2, and coordinates of C is x3 y3. Then how can I find it out, the area of triangle? So the area of triangle is given by one by 2 first x1, then y2 minus y3 plus x2 y3 minus y1 plus x3 y1 minus y2. So here is the area of triangle whose vertices are given in the form x1 y1, x2 y2 and x3 y3. So we can write it as x1 y2 minus y1 plus x2 y3 minus y1 and x3 y1 minus y2. Let us take an example. If I had given the vertices A as 3 comma minus 2, B as 6 comma 5 and C as 2 comma 1, then area of triangle ABC is given by 1 by 2 x1 y1 minus y2. Here I applied mod. What mod shows? Mod shows that the area of triangle will always be positive. It can't be negative. So applying mod here, x1 y2 minus y3 plus x2 y3 minus y1, then x3, y1 minus y2. So put the values here. We will get x1 is what? R3. y2 minus y3, 5 minus 1. With x2, 6. y3 is what? And x3 is our 2. Then what is our y1 minus y2? Minus 2 minus 5. So here we get 1 by 2, 3 into 4 plus 6 into 2. We get 12 plus 18 minus 14. So what is our area of triangle? Half into 16, that is 8 square units. As we know, area can be written by the square units. Okay? So I know that you got it by recalling all the concepts we have studied earlier. Now we will go for our straight line. Straight lines. As the name suggests, straight lines, we know that it is a line segment between 2 points in our Cartesian plane or coordinate axes. So how we studied about straight line? Can it be so simple like it shows as its name suggests? No, it is not so simple. For straight lines, first of all, we will study slope of a line. Slope of a line. As we know, what is our slope? Slope, that means inclination of line. Inclination of line from any axis. Let us suppose this is our x-axis. Let us suppose we have our coordinate plane. It is our x-axis and it is our y-axis, and we have a straight line passing through the origin. It is not necessary that it always passes through your origin, but here we let it as it will pass through the origin. So how could I find the slope of this line L? So first of all, I have to know what is the angle of inclination. We can find the slope of any line by two methods. First of all, by finding out the angle of inclination and by the coordinates of the line. So first here we will study how to find the slope of the line using angle of inclination. Here tan theta. Here the slope of this line L is tan theta, and slope can be written by the letter small m. So the slope of any line L is given by tan theta, where theta is the angle of inclination, where theta is the angle of inclination from the respective axis. Here we take the theta anti-clockwise from the x-axis. Now, if The angle of inclination for a particular case is 45 degree. If I have given the angle of inclination for any particular case is 45, then what will the value of my slope? Then it will be tan theta. So m is given by tan 45. What is a tan 45? That is 1. So here the slope of line L, any line L that is given theta equals to 45, I can find the slope is equals to 1. Similarly, for different angles, you can find different values of slope. What happens if I take it from this axis? So, if it is theta, then what will my this angle? This angle will be. Now, let us suppose if I had given a line L which makes an angle theta that is of 45 degree with the respective x-axis. So how can I find it out, the value of my slope? Then as we know, slope is given by tan theta. So here m is equals to tan 45. And what is the value of our tan 45? That is 1. If these angles are given, if you had given different angles, then you can find it out different values of the slope. So next we will start the slope of a line by coordinates. By using coordinate system, how can we find it out, the slope of any given line? I hope you understand what is the slope. The slope is the angle of inclination. The slope is the tan theta for the angle of inclination. And by the slope of a line, we can find how much the line is tilted from the respective axis. So let us now find the slope of any line when we had given the coordinate. So here again we have a line L, our y-axis, x-axis, and we had the coordinates x1, y1, x2, y2. And I have to find it out, the slope of this line when theta is not given. So how can I find the slope? We know that slope is given by tan theta, and if it is theta, then it can also be a theta, since we have a parallel x line with the x-axis. So if this will be theta, then this will also be theta. And for tan theta, we have the formula perpendicular upon base. So what is our perpendicular? This length, let it be A, B and C. So what is our perpendicular? Our perpendicular is BC. And what is our base? Our base is EC. If I had taken this triangle BEC, if in triangle BEC, as I know, if this angle will be theta, then this If this angle is given as the theta, then this will also be theta. So let us take triangle A, B and D. Here tan theta will be, what is our tan theta? BD upon AD. Since we don't have given any coordinates from that point and that point, so I taken this triangle ABD, so I can find it out the coordinates of the respective points. So if this total length is x1 and this total length is x2 and this total length is x1, so what is this length? It will be x2 minus x1. And similarly for this, if this total is y2 and this total is y1, so what is our BD? y2 minus y1. So I can write it as y2 minus y1 upon x2 minus x1. So when coordinates are given, I can find the slope by the formula y2 minus y1 upon x2 minus x1 if the theta angle is not given. Then we can find it as by this formula, and if the angle of inclination theta is given, we can find the slope of line by using m is equals to tan theta. Now let us take a case when the theta given is an obtuse angle. If the theta is an obtuse angle, how can we find it out? If theta is an obtuse angle, then how can we find it out the slope of a line? So here is my line L, and we can easily see that this angle will be an obtuse angle that is greater than 90 degree. So how can I find the slope of this line? If this is 180 degree, then this will be 180 minus theta. If the points A and B are given, x2, y2, x1, y1, then what is our formula? Our formula m is given by tan theta. Here the theta will be, what will be our theta? 180 degree minus theta. If this will be theta, then what is our theta? Here is 180 degree minus theta. So slope will be tan 180 degree minus theta. That will be minus tan theta. If angle is given and if the coordinates are given, so how can we find it slope of the line? Then slope is given by, here m is equals to minus tan theta, that is minus of AC upon BC. M is given by, what is our AC? y2 minus y1, and what is the BC? x2 minus x1 minus x2. Here this coordinate is our x1, so x1 minus x2 we will get the length of BC. So M is given by minus of y2 minus y1, and if I change this coordinate system to x2 minus x1, then I will take the negative common. So m is given by again y2 minus y1 upon x2 minus x1. Slope of the line when the angle is obtuse is negative when the tan theta is given, but for the coordinate system it doesn't change any formula for this. So here when angle is acute, we will get y2 minus y1 upon x2 minus x1. Similarly, when angle is obtuse, m is given by y2 minus y1 upon x2 minus x1. And when angle is obtuse, by the angle of inclination, we will find it out. M is equals to tan theta, but for the obtuse angle, we will get m is equals to minus of tan theta. Now, let us take an example for finding the slope of the line when coordinates are given. Find the slope of the line passing through the points 3, minus 2 and 7, minus 3. So, how can I find it out? First of all, recall our formula. M is given by y2 minus y1 upon x2 minus x1. Here, write x1 and x2 and the values of y1 and y2. What is our x1? That is 3 and x2 is 7. y1 is minus 2 and y2 is minus 3. So what we get? M is given by minus 3 minus of minus 2. That is y2 minus y1 upon x2 minus x1. 7 minus 3. So what we get? Minus 1 by 4. Here the value of our slope is minus 1 by 4. I hope you get that how we will find the slope of the line. So what next? We will discuss how we can find two lines are parallel or perpendicular to each other by the help of slope. By the help of slope, we will find the parallelity and perpendicularity of the lines. Now, we will discuss how can we find it out the condition of parallelism and perpendicularity by using the slopes of the lines. Let we have two lines given, L1 and L2. Then how can we find it out? The condition of parallelism. Parallelism, that means that both the lines are parallel to each other. For that we have to find their slopes. If their slopes are equal, then the condition is of parallelism. That means both the lines are parallel. So let us take, we have two lines parallel to each other. We have two lines parallel to each other, that is our line segment L1 and L2. Since let us suppose L1 is making an θ1 with the x-axis in anti-clockwise direction and L2 is making θ2 with x-axis in anti-clockwise direction. Then what will be the slopes? What will be the relation between the slopes, the angle of each other? We know that if two lines are parallel, then a transverse cuts them. It makes two equal angles here that are corresponding angles. So for the condition of parallelism, for the condition of parallelism, what we had given, θ1 be equal to θ2. Since it is two parallel lines and it is a transverse, so corresponding angle should be equal. If theta 1 is equals to theta 2, that means tan theta 1 is also equals to tan theta 2. And we recall from the formula of slope, tan theta is what? M, that is slope, and here tan theta 1, so I write it as M1 and M2, where M1 is the slope of first line and M2 is the slope of second line. So theta 1 is equals to theta 2 if two lines are parallel and their angles are equal, angle of inclination are equal, then their slopes are equal, and when the slopes are equal, we can say that two lines are parallel. So if we had given two lines and we will have to show that these two lines are parallel to each other, then first of all we will find the slope of both the lines and check whether they both are equal or not. So for the second condition of perpendicularity, how can I find it out? If two lines are perpendicular, then M1, M2 will be equals to -1. Then the product of both the slopes are equal to -1. Let us derive it. I had given an Cartesian plane. We have taken two lines, that is L1 and L2, where L1 and L2 intersect each other at angle of 90 degree. When both the lines are perpendicular to each other, then how could I find? If this is theta 1, then this will be theta 2. So slope of first line is tan theta 1. Similarly, slope of line 2 is M2, that is our tan theta 2. So we know that if this is our 90 degree, then it is also our 90 degree, that is right angle. Let ABC, then in triangle ABC we can find theta 1 is given by 90 plus theta 2. Theta 1 can be written as 90 plus theta 2. Triangle property, exterior angle is equals to the sum of opposite interior angles. So tan theta 1 is equals to tan of 90 plus theta 2. Tan theta 1 is equals to tan 90 plus theta 2. It will be minus of cot theta 2. Let us recall the chapter number 3 trigonometry. In that we have taken where there is the line changing line, when angle is respect to changing line, that it will change, that is tan is changes to cot theta, and in our second quadrant tan is negative. So this gives us tan theta is what are M1, and I can write it as minus of 1 upon tan theta 2. And we know that our tan theta 2 is what? M2. So m1 into m2 is equals to minus 1. This is the condition of perpendicularity. So if we had given two lines L1 and L2, they both are perpendicular to each other if and only if the slopes of the product of their slopes is minus 1. And for parallelism, if two lines are parallel to each other, in that condition the slope of both the lines should be equal. So now we will discuss the numerical on it. Let us take an example to find it out whether the two lines given are parallel, perpendicular or neither. That means neither parallel nor perpendicular to each other. So first of all, what we have conditions for perpendicularism. So condition for perpendicularism is m1, m2 is equals to minus 1, and condition for parallelism is m1 is equals to m2. And how can we find the value of m? So value of m is given by y2 minus y1 upon x2 minus x1. For line 1, m1 is equals to what? y2 minus y1, that is minus 4 minus 8 divided by x2 minus x1, that is our 2 minus 2 minus 12 by 4, that is minus of 3. Similarly, for line 2, what will we get? m2 is given by y2 minus y1. y2 is what? 2 minus 1. And x2 minus x1, that is minus 2 minus 5. So m2 is equals to 1 upon minus 2 plus 5, 3. So what is the value of our m1? Minus 3, and m2 1 by 3. Since we can see m1 is not equals to m2, so the lines are not parallel. So the lines are not parallel to each other. But let us check our second condition, that is condition of perpendicularism. m1 into m2. So m1 is minus 3 into 1 by 3. What I get? Minus 1. And what is the condition of perpendicularism? Slope, the multiplication of slope is minus 1. So here I get the multiplication of both the slopes are minus 1. So line 1 is perpendicular to line 2. So we can say that line 1 is perpendicular to line 2. Similarly, we can also find the condition of parallel lines. So in that case, we will have to find it out since m1 is equals to m2 or not. So here in this, both the lines given us are perpendicular to each other. Now we will find the angle between the two lines. If we had given two lines L1 and L2, how could we find the angle between both the lines? So for finding the angle between both the lines, we have to recall our previous knowledge of slopes. since this chapter is of straight line and we had studied in this chapter only about the slopes. So what we have studied about slopes? Slope of any line is given by tan theta. So here for line 1, for L1, what is our slope? For L1, what is our slope? Our slope is m1 is equals to tan theta 1. Similarly, for L2, m2 is given by tan theta 2. Here the slopes are not intersecting each other at perpendicular, so we can't apply the condition of perpendicularity. Here the slopes are intersecting, so we can't apply the condition of parallelism also. So how can we find? So let alpha and beta are the angle of inclination of both the lines on each other. That means line 1 made an angle of beta on line 2, and similarly line 1 made an angle of alpha on line 2nd. So how can we find? Here let us take A, B and C. A, B and C triangle. In this triangle I can see that interior sum of interior angle is equals to the exterior angle. So I applied here theta 1 plus beta angle is equals to theta 2. So beta is given by theta 2 minus theta 1. If I got the value of beta, then I can find the value of alpha also, since beta is equals to 180 minus alpha. So for beta, since I don't have values of theta 1 and theta 2, I had the values of theta, tan theta 1 and tan theta 2. How to change them in tan theta 1 and tan theta 2? So I applied here the trigonometric ratio tan. So now this equation becomes tan beta is equals to tan theta 2 minus tan theta 1. Let us recall our previous knowledge of trigonometry. Tan A minus B is given by the formula tan A minus tan B divided by 1 minus tan A tan B. So I can write it as tan beta is given by tan theta 2 minus tan theta 1 upon 1 minus tan theta 2 into tan theta 1. Now I know the values of tan theta 2, tan theta 1. So I put here tan beta is given by, what is our tan theta 2? It's our m2, that the slope of the second line. So it is m2 minus m1 upon 1 minus m1 into m2. m2 into m1 or m1 into m2. So from here I will now find the value of alpha. So we know that, how could I find beta is equals to 180 minus alpha. So tan beta is equals to tan 180 minus alpha. It is given by tan 180 minus alpha, that is second quadrant, and in second quadrant tan is negative, that is minus of tan alpha. So tan beta is what? Minus of tan alpha, and what is the value of tan beta? So I can write it as tan alpha is given by minus of m2 minus m1 upon 1 minus m1 m2. So if I know the value of tan beta, then I can find the value of tan alpha in the form of slopes. Let us recall our previous knowledge of trigonometry. Here we applied tan beta is equals to tan theta 2 minus tan theta 1. Since I don't have values of theta 2 and theta 1, so I know I have the values of tan theta 1 and tan theta 2, that is my slope of line 1 and slope of line 2. So I changed that theta 1 and theta 2 into the form of tan. So let us recall our previous knowledge of trigonometry, that is tan A minus B. Tan A minus B is given by tan A minus tan B upon 1 plus tan A into tan B. So I applied this formula here. What I get? Tan beta is equals to tan theta 2 minus tan theta 1 divided by 1 plus tan theta 1 theta 2. So from here I know that what is the value of tan theta 2? It is m2. And what is the value of tan theta 1? That is m1. So applying tan beta is given by m2 minus m1 upon 1 plus m1 m2. Since slope alpha is given by alpha, see here, how can I write the alpha? Alpha is given by 180 degree, beta 180 degree. So alpha can be written, beta can be written as 180 degree minus alpha. 180 degree minus alpha. Applying tan theta again, I got tan beta is equals to tan 180 minus alpha. So tan beta is given by minus of tan alpha. Since 180 minus theta is in second quadrant and tan is negative in the second quadrant. So tan beta is equals to minus of tan alpha. So from here I can conclude tan alpha is equals to minus of tan beta. And what is the value of our tan beta? That is m2 minus m1 upon 1 plus m1 into m2. So here we find the values of tan beta and tan alpha, that is tan of the angle between both the lines. So from these formula, now we conclude two cases. As we concluded from our previous derivation, the value of tan beta is equals to m2 minus m1 divided by 1 plus m1 m2. And similarly, tan alpha is given by m2 minus m1 negative of m2 minus m1 upon 1 plus m1 m2. So as we concluded from our previous derivation, that is tan beta is equals to m2 minus m1 upon 1 plus m1 m2, and similarly tan alpha is equals to minus of m2 minus m1 1 plus m1 m2, where m1 is the slope of line 1 and m2 is the slope of the second line. So from here, let us take case first. What is our case first? In which m2 minus m1 upon 1 plus m1 m2 is positive. If this happens, अगर ये tan बीटा पॉजिटिव हो जाता है तो क्या होगा? Then beta will be an acute angle and alpha will be an obtuse angle. if this, in this condition, if this is positive, if tan beta is positive, tan beta positive, that means all trigonometric ratios are positive, then they should be less than 90 degree, that means acute angle. And similarly, negative of that is when the values of tan theta are in negative, it means that belongs to the second quadrant or more than 90 degree, that means we get an obtuse angle. Similarly, second case, if m2 minus m1 upon 1 plus m1 m2 is negative, if this total quantity is negative, then we will get beta will be obtuse angle and alpha will be an acute angle. So I hope you got that. If we are given the slopes, we can find it out. The lines are parallel, the lines are perpendicular, or at which angle both the lines intersect each other. So here we will get the angle between the two lines. Since we get the values of tan alpha and tan beta, then we can also find the values of alpha and beta. Now next we will find out the collinearity of 3 points. Collinearity means that all the points A, B, C or given, if we had given A, B, C are the 3 points, then if they are collinear, that means they belongs to a single line. They all satisfy the equation of line L, then we will say that A, B, C are the collinear points. If they doesn't satisfy the equation of line L, then they cannot be the collinear points. But how can we conclude this collinearity? By using slopes. So by using slopes, we can conclude this collinearity by making the Cartesian plane, and in which I had taken a line L. On line L we had 3 points A, B, C. So we will now find the condition of collinearity of these 3 points. As it is shown, these points are collinear. So what will be the condition? Then this condition will be the slope of, if the slope of AB is equals to slope of BC, then we can say that the three points given are collinear to each other. Let us take the coordinate of point A is x1 y1, point C is x2 y2 and point B is x comma y. So as I know, slope is given by the formula y2 minus y1 upon x2 minus x1. So what is the slope of AB? The slope of AB will be y minus y1 upon x minus x1, and slope of BC is given by y2 minus y upon x2 minus x. So if this condition satisfied, if the slope of AB is equals to slope of BC, then we can say that the 3 points are collinear. So I hope you all get that points. Here the basic concepts before exercise 10.1 completes. Now we will discuss some numericals and exercise 10.1. So this will be continued in our part 2 of this chapter. Now thank you so much.